Hello and welcome to the video on working with images in Python. We will be using OpenCV as our library to work with images in Python. This is because OpenCV is predominantly used by many programmers all around the world and it has many functionalities that other library lacks. First, let's import OpenCV. OpenCV is called CV2 in Python. Then we'll also import matplotlib to print the image. We'll also be using the NumPy library. The image that we will be working with is lena.png and this is the image. I'll be creating a variable img and I'll use imread function from OpenCV to open the image. I'll be passing the name of the image into it. And now let's use matplotlib to print it out. Here we can see that the image is quite different from the original image. The original image is reddish in color, but the image that is getting printed is bluish in color. This is because OpenCV perceives images in BGR format rather than RGB format. So, the blue and the red channel is getting interchanged. So, the places where the red color is present is replaced with blue color. To convert the images into RGB format, we have to use convert color function. So, I will be using cv2 dot convert color and then I will pass the image into it, followed by cv2 dot color bgr to RGB. Now let's print the image. Now we can see that the image is in the correct form. Let's also print the shape of the image. Here we can see that there are three channels and this is the width of the image and this is the height of the image. We have discussed in the previous videos that a color image has three channels R, G, B and every value in it represents the intensity of that particular color. While we combine those three channels together, we get the colorful image and this actually represents it. We have three channels representing RGB and the pixels in it. Now let's try to print the pixel values in one channel. So first I'll write print image and inside the square brackets we'll be choosing only the one channel from it. So I'll go to the third index and choose one channel out of it. What about the other indexes? These two represents two dimensions. One is height, the other one is width. So, and we need all values of it in that particular channel. So, I will be using the semicolon here. Now, let's print it. I will shift enter this cell and we get an output. These values are the pixel values present in one channel. Let me also print the shape of it to make you understand it better. Here we get the output of the width and the height, which represents these are the values present in one channel. Now, what if you want to resize the image in a particular dimensions? Because Sometimes machine learning models requires the image to be in particular size. For this, we can use the resize function. So now I'll create a new variable called I and let's access the resize function from the CV2 library. Inside it, we'll pass the image and the new dimensions that our image should be. So I'll pass 750, 540. After this, let's plot the new image. This is the resized version of our old image. So this is our original image and this is the resized image. To make things clear, I'll also print the shape of the new image. Here we can see that we get 540, 740. You might wonder why the numbers are interchanged. This is because the width and the height are interchanged in OpenCV. Now let's try some more functionalities that are available in OpenCV. First, let's rotate the image. For this, let's use the rotate function from the OpenCV library. So cv2 dot rotate, and here we'll pass the image and the degree to which the image should be rotated. So let's enter cv2 dot rotate and let's choose 90-degree clockwise. This will rotate the image to 90-degree clockwise and the new variable will be im, and let's plot it out. So I'll use plt.imshow and I'll plot the rotated image. Here we can see that the image is rotated to 90 in clockwise direction. Let's try some other functions like edge detection. So now we'll apply a filter to the image which is called canny filter, which will detect the edges in the image and plot it out. So for this, first we have to convert the image to black and white color. So let's take the image and let's convert color of it. So I'll use the convert color function, pass the image into it and then use cv2 dot color. Now that we have converted the image to RGB, let's use the RGB function itself. So color RGB to gray. And here let's name the new image that will be getting as image underscore gray, and this will be passed to the canny edge filter. So let's create a new variable called edges, and from cv2 let's access the canny edge filter, and inside it let's pass the image into it and apply some threshold values to the filter. After this, let's plot the image and check how the edges are getting printed. So I'll be plotting the edges image and let's use the cmap function in matplotlib to print the image in black and white color. This is because cv2 is different from matplotlib. Here we can see that the edges of the image are getting printed. You can also use cv2.imshow function to print the image, but I use matplotlib to print images in this because matplotlib usually plots the image inside the notebook itself, and this is comfortable while working with images and doing some analysis on it. I hope you understood about how to work with images using OpenCV library in Python. See you again in the next video.